Okay, so here's the explanations of the first review packet of the year that we're doing. Like I told you, we'll get one for sure every test day to review prior material to keep things fresh. Don't forget, on all future tests as well, I'll have review problems, so you could even see some of these either exact problems or similar problems this in addition to the current material on your future tests here. All right, here we go. If two lines in the same plane, that's the key word, and they even have it underlined here, do not intersect, the lines must be parallel. That is true because they're in the same plane. Notice what it says here. If two lines in space do not intersect, the lines must be parallel. They do not have to be parallel. They could be skew. Okay, so uh, they may be parallel, but they could also be skew if they're in space. If they're in the same plane, they must be parallel. And if two lines are parallel, the lines must lie in the same plane. Yes. Okay. All right, here we go. Scale factor. Again, we have overlapping triangles if you want to think of it that way. Okay. Even though they're only talking about these individual segments, but you can think if you drew a triangle, there's overlapping in one. This one's the smallest, obviously this one gets bigger, and this one is the biggest. So if the scale factor of the dilation is k, which the statements, so that's going to tell you if it's getting bigger or smaller, k is. That's what scale factor is. Okay. If k is greater than 1, it's called an enlargement. If k is between 0 and 1, um, or between, quote, really between -1 and +1, it's a reduction. Okay, the dilation is a reduction. If it's greater than 1 or less than -1, then it's an enlargement. And we'll talk more about that later, okay, as far as the negatives are concerned. All right, so if k is greater than 1, the image of ST, so that means that this is the pre-image, could it be QR? Remember, if it's greater than 1, it's getting bigger, so it cannot be QR. It would have to be UV. If k is between 0 and 1, the image of QR could be UV. No, that got bigger. Between 0 and 1 is going to get smaller. Give me a reduction. If k is greater than 1, the image of ST, again, this would be the preimage, could be UV. Yes, it got bigger with k greater than 1. Number 4 here. If the same length of segment BC, or that's what it means, the distance from B to C, because there's nothing above it, equals x, what's the length of segment ST is what they're looking for. Well, in order to know that, I need to compare two other corresponding sides and see their ratio. So here, the ones I'm looking for is a vertical one or a horizontal. This isn't vertical, that's oblique, and oblique, so that's going to be harder. You know, you have to do Pythagorean theorem and compare it that way, much more work. It's easiest always to look for a vertical segments that are corresponding or horizontal because you can just straight count them. So here's 3 and that's 6, so that means it doubled, okay, in size. So the k, if we're talking about k up here, that would have been 2. Okay, so again, since that's x, then st is 2x, double it. Next, write an equation of a circle. Which equation of a circle with center h? So look right here, the center is 4, 2. So I wrote 4 here. So we got to remember from writing our standard form of equation, it's x minus h squared plus y minus k quantity squared equals r squared. So we're looking at the opposite, okay, and then the square root of whatever this number is would be the radius. So only these two have centers of 4, 2. Both these centers are -4, -2. Okay, so those you can immediately wipe out. So now it comes down to these two, looking at the radius. So this is saying, remember this is r squared right here. So this is saying r would be the square root of 10, which is just past 3. Well, if I count 1, 2, 3, it's just past 3. So that tells me it's this one. This radius would be the square root of the square root of 10. It's going to be the square root of 3 point something, even smaller, like 1.7. Okay, something like that, which is not the radius. All right, here it wants you to complete the square and find the center and then figure out which letter up here has that center. So you're finding the equation of one of these other circles. So again, we match up our x's together, our y's together. We have plus blank after the x and plus blank after the y. Okay, the constant goes to the other side. To complete the square, we always do half of b right here squared. So half of negative 3 squared is positive 9. Half of 2 squared is 1. Half of b is 1. Squared is 1 still. So we really added 10 to the left side, so we want us to add 10 to the right side. That's why we had the plus blank over here, and that's the 10. Make sure the 10 here is the same as the 10 here. So then there, 10 minus 5 is 5. And then this is a perfect square trinomial from algebra 1. It's always going to factor into the square root of x squared x and the square root of 9, 3, and you take the middle sign right here. The linear coefficients sign right here, negative. Or that's the same thing as saying whatever half of b is goes right there. Okay, so again, y square root of 1 is 1. This sign, positive. Don't forget you have parentheses on both, squareds on both. Okay, and then so the center we know is opposite opposite, and the radius is square root. So opposite and opposite gives me 3, negative 1. So I go to 3, 1, 2, 3, negative 1. There the center is I. So there's my circle. Okay. Again, these are types of problems you could have on the DCAS. Remember, these release park items already. Okay, so these types of problems you could easily see. Okay, that's why I'm explaining every time we do one of these packets, I'm going to explain every problem so you can review this, watch the video again, hear all the explanations back again in April, whether that's over spring break or right after spring break, to get all the stuff refreshing in your mind. All right, so we have this triangle shown here. It says, under which transformations will the image of the triangle ABC be similar to the preimage? Similar means it's either congruent or it's a dilation, which means it's an enlargement or reduction. If k is greater than 1, it's an enlargement. If k is less or between 0, technically between negative 1 and 1, a reduction. And those are dilations. Okay, so we look up here. Negative xy to negative xy is a rotation of 180. It takes it from quadrant 1 in this case to quadrant 3. So that's going to be congruent, which is similar. That means the ratio is 1 to 1 for congruency. Okay. Now, if they were to say similar but not congruent, then we need to take off the rotations and the translations, and there would only be a dilation only. Okay, but technically, by this saying similar, it can be congruent, a ratio of 1 to 1. So here we got to look at this is nothing. This is actually change the shape. It's only move the x to the right, but it's multiplying the y side double. It's lengthening the y's length. Okay, so that's going to be completely changing the shape. Here we have a dilation. The reason we know it's a dilation is because it's multiplied by the same coefficient. Since that's between 0 and 1, we know it's a reduction of a half. That's how you represent a reduction of a half. If I want to be double the size, it'd be a 2x and 2y. And that's a dilation of scale factor of 2. So as it points out here, the scale factor is 1/2. They both have to be the same. And they're multiplied. Okay. And this one down here, so obviously it's a dilation, so that works. That's similar. And this one here is another translation, not another one because the first one here that we've seen over and over. So the translation, that means to be congruent, which is also similar. And this one changes, doubles the x sides, but triples the y's. So again, that changes the whole shape. So these two would not be a dilation or an isometry at all. Okay, these three are the dilation, are the dilation here, and the translation and rotation. Okay, so those are your three answers. This one we haven't done in a while, and I forgot, I think, to put it on your test. We did it as homework, but I forgot to put it on your quiz or your test. When we were going over it. So we need to remember, I'll review the vocab again. Remember, any angle that is formed on the circle here like this is called an inscribed angle. And that inscribed angle always equals half of its arc. So the arc that forms angle PKQ, that arc is PQ. So whatever angle measure this is, say that's 100, let's just say that's 100 degrees, then this angle will be 50, half of it. Okay. Now what other arc goes along with this? or what other angle goes along with this arc? This angle right here. Because again, you see it connected to P and connected to Q. So this also is 50. So these two angles are actually congruent. So I could put congruent symbols on these ones right here. They're both, in this case, 50 degrees if that was 100. Okay, and don't forget, this is called a central angle because this angle is connected to the center. So it's called a central angle. The central angle equals the arc measure itself. So that means this would be 100. Okay, for that angle right there. Okay, and don't forget these then two are both 50, half of its intercepted arc. Okay, so let's see which one says that. PKQ, this angle is half of PNQ. Nope, we just said they're congruent. So that's false. This obviously the answer will come back. PKQ equals PCQ. No, this is 100 and this is 50. This again is half of that. So that's false. PKQ equals 2 times this one. No. Um, it's half of this one. Okay, so that's what we see right here. PKQ equals half of PCQ. Okay, so it's B right there. You gotta remember inscribed angles. Half of these intercepted arc, central angle equals its arc measure. All right. In the figure below, DE connects the midpoints. So that means this is a mid-segment. Okay, and we talked about that. And so that means those are midpoints, these are midpoints, and we know with mid-segments, they're parallel to the base. It's half the distance of the base. Since these are parallel, we know these angles are congruent, corresponding angles are congruent, and this angle B is congruent to itself. These two triangles, therefore, are similar, okay, by AA similarity, all right? Um, and they're overlapping triangles. They're called overlapping triangles, and they're also a dilation centered at B. Okay, so this is a dilation of 2 compared to this preimage. If this is the preimage, the dilation here would be 2 times. If I went from here, the big one, as the preimage to the small one, it'd be a dilation of 1/2, called a reduction. Okay, so that's all the vocab relating to this. So now let's go ahead and find out. This is which one cannot be proven. Is DE parallel to AC? Yes, it is. Is 2 times the mid-segment equal the base? Yes, it does. Are the two triangles similar? Yes, they are by AA similarity. You didn't have to know the name of it, but that's what we're going to be studying now, right now, next class in Mod 2. Okay, uh, but you can just tell they're similar. One's just bigger than the other. Okay, and so this is the one that's not true. Notice this BD over DA. So this segment over this segment, it would have to be BE over EC, the exact same on this side. But what does it say? DE over AC. So DE is the entire length of the small one, which is what BD is. But AC is the entire length of the big one. Notice this DA is not the entire length of the big one. The entire length of the big one on this side is BA. So if that said BA for the entire length, then this would be true. But it only does a fraction of the entire big triangle. Okay, so this is false. So you got to be paying attention that it matches up the corresponding sides or segments correctly. Whatever's on one side must be the exact same on the other side. So you want to think in terms of, okay, this is the full length of the small triangle. This is a part length of the big triangle. The entire length of the big triangle is from here to here. And same on this side. And then here, this is the entire length of the small triangle, and this is the entire length of the big triangle. Okay, when we talk about different side segments and how to compare them, think of calling them those things right there. So you make sure that whatever proportion you set up when we start doing these as problems, that you set up the right corresponding parts correctly. All right, next here, we're doing an angle bisector. Again, this is from the Parcc. I told you angle bisector is the most popular one that they have on the Parcc. There's a good chance you're going to see it again this year. I think it's been the last 2 years as well. They wanted here to order the angle bisector. I think you even saw that on your decast post-mod decast test itself, you ordered angle bisector. I think you ordered one set of constructions, but angle bisector is again the most popular one. And so here's my order. First thing I do is put my pointer here, draw arcs with the same radius centered at P that intersect both this ray and this ray. So I draw this arc. Okay, I get my Y and the A right here. 2, starting right here, draw two arcs, intersecting arcs with the same radius, one centered at Y and one centered at A in the interior uh, right here. So I draw my two arcs. I get those two right there where they intersect. 3, name the intersection of those two arcs X. Here's the X right here. So this had to come after you drew the two arcs. So 1, 2, 3. And lastly, you go ahead and take your straight edge and connect P through X to get your angle bisector. Okay. Now, I'd ask, how do we know that once I've drawn this angle bisector, how do I know that these two triangles right here are congruent? S, S, S. And don't forget, I gave you this on the video earlier in the year. I told you they're going to ask about these different sides and also how this relates. And in this case, how the two triangles are congruent by SSS, side, side, side. This one is where I told you, we've seen it before, where they actually ask about the individual, each step 1, step 2, and step 3. So I can go back up and just use it. Step 1, I get these two congruent. Step 2, I get these two being congruent. Step 3, after I draw that, it's reflexive congruent onto itself. That's what it's asking. Again, I pointed this out on the video earlier in the year. So you're naming those three. AB is congruent to AC, that's true. BD, that segment is congruent to CD, that's true. And AD is congruent to itself, reflects your property of congruence. Okay, there's those three. And based on the construction, what two angles must be congruent? Obviously, we just did an angle bisector. So this angle must be equal to this angle. So just naming the angle correctly. BAD and CAD congruent. All right, next. We have the figure shown as a circle with center E, diameter BC. Remember, diameter goes through the center. And DG is a tangent. Remember, tangent means it only touches, it's outside the circle, it only touches the circle at one point on the circle. And then you got to remember from earlier on, we looked at characteristics of a circle, that a tangent is perpendicular to the center. When I connect that segment to the center of the circle, it's 90 degrees. Again, earlier vocab, we studied the circles. Okay. So it says, which of the angles must be right angles? Well, obviously we know that one. We just put it in there. Okay. So that's EDG, this last one right here. Now, don't forget, since this right here is an inscribed angle, it equals half of its arc. So if we know it's going to be 90 degrees, it's going to connect to the ends of the diameter. We even had this problem earlier when we were studying the circles. So that means this angle BDC right here has to be 90 degrees. It's half of its arc, which is 180 degrees, semicircle. The other one we have is BFC. BFC. Notice this is an inscribed angle and it connects at the ends of its diameter right here. So it's half of this semicircle, which is 180 degrees, half of 180 is 90 degrees also. Okay. If K can be located anywhere on points C and B on the semicircle CFB, so it has to be on this side of the semicircle, not this side. See, it says CFB. So C through F to B. So it's telling you it's going to be anywhere along here. So I just put it right there as an example. Okay. Which of these could also be a right angle? BCK, B, C, and K. No, if I connect that to here, remember this angle will only be half of this measure. That's not 180 degrees. Okay. BDK, BDK. Again, if I connect this right here, and this is not 180 degrees. Okay, we know BDC is 180, that arc is, which is why it is there. CDK, CDK, if I connect this right here, it's going to be half of that arc. Well, that arc we know is not 180 degrees, so that can't be the 90. Now DCK here, DCK. So if I connect this now, okay, DCK, this angle is half of this whole arc. That arc could be 180 degrees, okay, depending on where I put the K. Okay, that's a potential to be 180 degrees, which means half of that would be 90. So that is why it's DCK right there. All right, here we got equations of circles again. Okay, find the radius. Okay, and the center for part A. So again, we get the x's and the y's to one side, the constants to the other. Okay, put the x's together, put your plus blank, y's together, plus blank. Half of b is -5, squared is +25. Half of 2 is 1, squared is 1. So we really added 26 to the left side, so we have to add 26 to the right side. 26 minus 17 is 9. So remember, that's r squared, so it tells me the radius is 3. And again, this perfect square trinomial factors into this. This perfect square trinomial factors into this. And we do opposite for the center, so 5, -1. Okay, so we have those filled in. Part A now here, down here, says, in this one, we have this right here. If the equation of a circle is written in this form, where k and c are constants, what's the value of k? Okay, so again, we just complete the square. There's nothing else with x, which is x squared. So let me know it's 0 for the x coordinate. And I take half of b, half of 6 is 3, squared is 9. And since I added 9 to the left, I must add 9 to the right. Don't forget I'm moving that constant across, adding 9 to the right since I added to the left. So I get 13. So the radius is the square root of 13, which is in the second part B's question. What's the radius? Square root of 13. That's the exact answer. And here's my y plus k. They want to know what k is. K is right there, 3. So you put in a 3 there. Now what's key to pay attention to is this is a plus sign here, this is a plus sign. If this had said y minus k, don't forget, since this says plus 3, then it'd be y minus a -3 in order to get that plus 3 there. So that said y minus k, then k is actually -3 to end up with a +3 right there. Okay, so that's key to pay attention how this is set up, whether it's plus or minus. All right, which geometric figures can you measure? Obviously, you can't measure a line. It goes on forever in both directions. You can't get that distance. Okay, it goes on forever. You can't do a point. Point, remember, has 0 dimension. There's nothing there, so you can't measure that distance. You can measure an angle, and you can measure a line segment. Again, a race starts somewhere and goes on forever, so you cannot measure that. So it's only these two. And that is it. 23 minutes.